consists of nucleus, and inside nucleus are protons and neutrons, and outside the nucleus there are many electrons. And we already told that talked that number of protons, it's like ID for atom, so it's identify will it be carbon or it will be oxygen. For example, let me give you an example. Every atom with number of protons in its nucleus equals to 1, it is hydrogen. If number of protons equals to 7, it is nitrogen. So number of protons inside the nucleus, it's like ID for every atom. And as atom is neutral particle, so you know that means that number of protons always in atom always equal to number of electrons, right? So if we have hydrogen, number of proton 1 equals 1 to 1. That means that electrons number of electrons is 1 too. So and for nitrogen it will be number of electrons equal to 7. But we didn't tell anything about neutrons. Why? Because the number of neutrons is not really the same for element, for atoms. There are isotopes. Isotopes they are atoms that have the same number of protons but different number of neutrons. Here are given 3 examples of isotopes of carbon. So carbon 12, carbon 13, and carbon 14. 14. What does that mean? 12, 13, and 14. That means it's mass number. So carbon 12. Carbon mass number goes on top, and as it is carbon, we can take a look at our periodic table, and you can see here 6, its atomic number. Go back, atomic number 6 goes to the bottom. Okay, so that means that this carbon has 6 protons, 6 electrons, and how we calculate that it is 6 neutrons. 12 mass number minus 6 number of protons equals to 6 neutrons. So carbon 12, or you can say isotope carbon 12 has 6 protons, 6 neutrons, and 6 electrons. Carbon 13. Carbon 13, the symbol will be still carbon. Carbon and its atomic number in periodic table is 6. 13 is its mass number, so 13 goes on top. And let's calculate. So 6 protons, because just remind you, number of protons always equal to atomic number. 6 also 6 electrons, but 7 neutrons. 13 mass number for this isotope carbon 13 minus 6, which is number of protons, gives us 7 neutrons. And also for carbon 14, 6 atomic number, 14 mass number. It has 6 protons but 8 neutrons. Why? Because 14 mass number minus 6, the number of protons. So 14 minus 6 gives us 8 neutrons. And you can see what is the same. The same here is, let's take another. The same is the number of protons equals to atomic number. The number of electrons equals to number of protons. But what is different here? Different here is number of neutrons. So isotopes are atoms that have the same number of protons but different number of neutrons. And we need to fill this table. So no drawing anymore. Okay, so fill the table. Oxygen 16, oxygen 17, and oxygen 18. These are isotopes too of oxygen. We are going to periodic table, find oxygen here, and you can see oxygen, its symbol O. Atomic number is 8 and mass number is 16. It's average. It's average. But oxygen exists as oxygen 16, oxygen 17, and oxygen 18 in nature. So, number of protons. As it is oxygen, it will be 8 because oxygen 8 is atomic number, 16 mass number. Okay? Number of neutrons, 16 mass number minus 8 gives us 8 neutrons. And number of electrons, the same as the number of protons, 8 electrons. Okay, so let's move on to oxygen 17. Oxygen 17, 8, because it's still oxygen, 17 here. Number of protons, 8 protons. Number of neutrons, 17 minus 8, which is 9 neutrons, but 8 electrons. Oxygen 18, 18 here, 8 protons. Number of protons is the same. Number of protons is the same because it is oxygen. If it is like 9, it will not be oxygen. If it is 7, it is not oxygen too. It's another element, okay? So number of neutrons, 18 minus 8 equals to 10 neutrons, okay? And number of electrons in neutral atom is the same as number of protons, so that will be 8 electrons, okay. So let's define true or false. The protons and neutrons are packed in the nucleus. Yes, it is true. Neutrons and protons packed in the nucleus and electrons outside the nucleus. Okay. B. The number of protons and neutrons is always the same in a neutral atom. And you can see it's not actually true because the number of protons, yes, it is ID for atom, so it is it defines atom. But the number of neutrons can be different, as you can see here, for carbon and for oxygen, for their isotopes. So no, it is false. The electrons occupy a very large volume compared to the nucleus. Yes, it is true. And if we imagine that our electron like a football, so our atom can be like football field, so much more bigger. So it is true. Almost all of the mass of the atom is concentrated in the nucleus. Yes, it is true too, because the mass of electrons is almost negligible, very small. The number of protons and electrons is always the same in a neutral atom. Yeah, neutral atom. And I put these words like neutral atom in purpose. But for scientists, it's like, say, oily oil, or I don't know, so like wet water. So neutral atom, you don't need to say that. If you say atom, that means that it is neutral. But special for you, to make you don't forget about this, right? I put it here, neutral atom. Yes, number of protons and electrons equals to each other. Yes, it is true. And an atom has a charge? No, it is not, right? So it is false. It's neutral. Why? Because number of protons equals to number of electrons. Okay, complete the chart. It is given symbol of element S and its atomic number 16 and mass number 31. We need to find number of protons, neutrons, electrons, and so on. So you can write down just for you its atomic number, right, and its mass number. Okay, so number of protons. Number of protons is the same as atomic number, equals to atomic number. So atomic number is 16. That means this atom, it's sulfur, has 16 protons. Okay. Number of neutrons. Number of neutrons we need to calculate. So mass number 31, it's on top, minus atomic number, which means number of protons, minus 16, equals to 15, correct? Okay, 15 neutrons. Okay, number of electrons. Number of electrons, the same. You can write down here, or we have it already. So number of protons equals to number of electrons in atom. Okay, so it is atom. It has no charge here. Number of electrons the same, 16 electrons, and atomic number. Atomic number is 16 and mass number 31. And here we need to go back from right to the left. Okay, so we have mass number, we have atomic number. Atomic number gives us number of proton, which is 15, correct? 15. And gives us number of electrons, 15 too, right? And number of neutrons we can calculate. So 31 minus 15, 16. And I have a question. So these elements, the first one and the second one, are they isotopes? Are they isotopes? Let's read again the definition. Isotopes are atoms that have the same number of protons but different number of neutrons. Number of neutrons Different, yes. But do they have the same number of protons? No. That's why they are not isotopes. They are two different elements. So actually go to the periodic table. 15 and 15 you can see it's phosphorus. Okay? 15 it is phosphorus. 15 and 31. Okay, so that was about isotopes. Practice problem set 2 you will finish by yourself, and I didn't mention it before, but I am mentioning this now. Please, when you scan your handout, scan all pages. Please, what I write down here and what you will do at home by yourself, because I need to see, do you understand what you are doing? Maybe you made some mistakes, and that will be a good time to, to give you feedback, okay?